Okay, we have to, so radians and degrees. You're used to working in degrees, but we have to lay a foundation. Shh, I know you're having fun back from break, but it's time to shut up about that. We have to lay a foundation where we can measure distance and time. Okay. Degrees is a very circular measurement. So if you're standing around, okay, do you measure height in degrees? No. Do we measure time in degrees? No, we don't. So we need some sort of a system to map these sound waves out. Okay, we need a real number system. So it's called radians, right? Radians are based on, guess what? The unit circle. Yay! Okay, fingers do not work very well for me on these. Oh well. Okay, what's the radius of the unit circle?
360.
Dude. Okay, I'll give you the degree measure, 360 degrees. So we need that, but R is 1. Thank you for that. Comic relief for the day. What's the circumference of that circle? No. What's the formula? Okay. Right? 2 pi r or pi d, one of the two. So that gives us the outside length. It gives us the length of this circle, right? The our outside, the circumference. Okay. Get our mind straight here. So what's the circumference of that? If you round, it's 6.28. We're going to leave it in 2 pi. 2 pi is the number of radians in 1 revolution. So 2 pi is how many degrees? One revolution's 2 pi radians. Yeah, 360 degrees, right? So we can actually come up with a conversion to go from radians to degrees. Okay. So if I have 360 degrees is 2 pi radians. Two pi. So we want to get 1 radian is equal to 180 over pi. Okay. So that's 1. So now we can divide by 360. This is just the other direction. 1 degree is pi over 180 radians. Notice the similarities there. It's just a reciprocal. So this is about 57.3 degrees, and this is 0.017 radians. So we can go back and forth. Because he's awesome. That's why. That's 300 degrees. So we're going to convert 300 degrees to radians.
Yeah.
Which one of those do I use? Yeah. So 300 times pi over 180. Now this is where we don't use decimals again. We're going to leave it in fraction form. Okay, I'm going to show you why we leave it in fraction form. So we have to simplify it. What does that simplify to? What's 300 over 180? It's divisible by 20, yeah? Oh, 60 even. 5 pi over 3. Radians. Yeah, radians are rad. Thanks for that. You were just waiting for me to pull that one out, huh?
Yeah, I thought you were going to.
Radians are cool. And then you can do the same thing. Let's say convert 4 pi over 3 radians to degrees. Which one do I use? Yeah, that one right there. So times by 180 over pi. The pi's cancel, right? Top and bottom, they cancel out. Okay, so one thing, this is how I remember it. When I'm going to degrees, I don't want a pi in there, right? So I need the pi on the bottom, which tells me which formula to use to get rid of that pi. So I just remember it because I need to eliminate a pi to get degrees. That should be 240, right? Yeah. 180 divided by 3 is 60, times 4 is 240. You'll manipulate that whatever way you need to. Okay, this is where paying off fractions, this is where fractions will pay off for us.
No.
On the unit circle, we can do, you know, I asked you about cosine 30 or sine 30 on the warm-up. We can do the same thing with radians on the unit circle. Okay. Whoops. There we go. So the warm-up, was sine of, was a sine of 30 degrees, right? That was 1/2. We can do the same thing with radians. What's this 30 degrees in radians? Yep. You had that memorized, didn't you? Those two are equivalent statements. Okay, 30 degrees and pi over 6 radians are the same measurement. Okay, so if you need to for now, you can switch back and forth. I prefer now to work in radians. It's much easier. Pi radians is how many degrees? This should be easy. 2 pi is a full revolution at 360. Pi is 180, yeah. Okay, so let me write a few of these on here. See, that's pi radians. This is pi over 2. What degree measure is that? From here to here? Yeah, 90 degrees. Okay, what about this one? It's 270 degrees. How many radians is it? Fraction. This is 1, right? And this is 2. What's that one? Yeah, what is that in a fraction though? 3 pi over 2. Know that fraction. 3 over 2 is 1.5. Okay. Pi over 2 is 1/2 pi. Okay, and then we can fill in all the spaces in there between. Okay, 30 degrees is pi over 6. 45 degrees is, anybody? 45 degrees, somebody decides it here, is halfway to a half. What's that? 45 is halfway to this, right? To 90. So what's that fraction going to be? This is a half. That would be a quarter. Thank you. Okay, 45 is a quarter. 60 is a third. Because it's 1/3 of the way to 180, right? So 1/2 or 1/4, 1/3. And then here you get to 2/3, which is 120 degrees. This would be 3/4 pi, which is 135. And then 5 pi over 6 is 150 degrees. Okay. There's a table in your book. Crack that open out. What page is it? Okay. It is 344. Okay, 344. There's a table in your book. You were on the right page. You were. 344.
Oh, I think so. 344. Oh, sweet.
I'm going to cry. She just called me horrible. Awesome.
I didn't know that. Like my first 2 weeks there, so I
Jerk. Yes, awesome. So you're on page 344. You have a table. So what's 225 degrees? Yeah, it's 5 pi over 4. So the reason I like radians better is because it's, you know what 1 pi is, right? We're only 1/4 past that. So if this is 4 pi over 4, this is 5 pi over 4. I can just split it into fourths. 1, 2, 3, 4, 5. 5/4. Okay, so that's why I like radians. They work better. They're a real number. You can measure time with them. You can measure a whole bunch of things. We do calculus with radians, not with degrees, because it's a real number. Calculus is a mathematics of the real numbers. So radians and degrees. Be able to convert between the two for music purposes. We're measuring in time. Your sound waves are measured in time. We needed radians to be able to measure that time. Okay. Do you have any questions? All right. We will have homework quite a bit. Most of it will be review stuff. Okay, you'll notice the mixed reviews, about half the assignments. I also have the Chrome cart reserved every day except Friday because it was already taken. So I'll have that in here. You guys can choose to work on the homework or the project. Okay, when we're done with the formal stuff. Okay. So we have about 35 minutes. Right now you should have your music, your chords chosen, your music piece, your chords and your notes broke down. Okay. Do we need to go get the cart?
Yes.
Who wants to do that?
Here.
All right, boys. You can go if you want. So you can work on this, or you can work on your projects. You can start writing your reports. All right, it's up to you.